So in this problem, I'm going to do question number 14, and it's actually a segue into question number 15. So question number 14 says you have 5 charges in space, and they all happen to be along axes, so these are basically axis aligned. So I'll draw the diagram. So we're told that we are charges, so here is Q1. And Q1 has a charge of 3 coulombs and it's located, 0.4. So Q1 is 3 coulombs. So let's just say Q1 is equal to 3 and it's located at 0.4. So 0 in the x direction, and so here's your y-axis and here's your x-axis. It's not drawn to scale. Q2 is given as 5.0. So here's Q2. And it's, oh, I'm sorry, Q2 is negative 2 coulombs, so it's negative 2. So make sure this is minus 2 coulombs. And then Q3 is 4 coulombs at 0, negative 6. So this is Q3. I'm tired, it's late. Q3 is 4 coulombs, so this is 4. And it's located at 0 and negative 6. It's negative 6. Sorry. So here's Q3, which is 2 coulombs at 0 and negative 6. So that's somewhere down below. Oh, I'm sorry, this is 4 coulombs, so 4. So you have Q3, and then you have Q4. Q4 is given by 5 coulombs, and it's located at negative 3, 0. So this is at negative 3 and 0. My diagrams are kind of small, but hopefully, and there's a 7 coulomb charge. So this is at Q5. So this is right at the center. So Q5 is equal to negative 7 coulombs. Is it negative 7? Yeah, it's at the origin. And so our problem is we have to find the sum of all forces, sigma F, along sum of all forces on the 5th charge. Sum of all forces on the 5th charge, which I'll denote by charge number 5. So to find the force, we have to take the force of 1 acting on 5 plus the force of 2 acting on 5 plus the force of 3 acting on 5 plus the force of 4 acting on 5. And you might think this is kind of really difficult because our unit vectors, right, for directional is like kind of really long. But lucky for us, the directional vectors we already know. So we can actually do this pretty darn quickly. So it's K. The Coulombic equation is going to be Q1 times Q5, and the distance between 1 and 5 squared. Now the directional vector is going to be R15 hat. And the next equation is going to be the same thing. It's K times Q2, Q5, all divisible by R25 squared, R25 hat. So the directional vector from 2 to 5. And K times Q3 times Q5 over R35 squared. So this is our Coulombic equation of 3, 5 arrow. So the unit directional vector in the direction 3 to 5. And the last, is it on the board? Yeah, it's on the board. Plus K, Coulombic constant, times Q4 times Q5, all divisible by R45 squared, R45 hat. So Normally, if this was generally in space, it's a lot of heavy calculations, but we don't have to do heavy calculations. We can actually plug in things really quickly. So we can say K is 9.0 times 10 to the 9 standard units. Q1 happens to have value of 3. Q5 has a value of -7. And now, what is the distance from R1 to 5? So R1 to 5, notice the distance is along the x-axis, so it's really just 4 units. We can say it's 0 squared, square root of 0 squared plus 4 squared, but we know the distance is 4, so I can just write down 4 squared. That was easy. And what's the direction from 1 to 5? What's the direction for pointing down? It's -j, so I can write this as -j. The directional vector from 1 to 5 is pointing down. The directional vector is pointing down. That's -j. I already have directional vectors. So the next equation will be 9.0 times 10 to the 9 standard units, which 2 significant digits. Q2 is 5.0, let's just say 5. And Q5 is -7 again. And what's the distance between Q2 and Q5? In this case, it happens to be 5 zeros along 5 units. So we can just say it's 5 squared. And what's the directional vector of 2 pointing in the direction 5? It's -I. It's pointing this way. The directional vector is -I. And I can repeat again, 9.0. Is there enough space to put this all in? I hope so. Else you'll have to continue on this side. 9.0 times 10 to the 9, which is really 8.99, but 2 significant digits, it's going to be constant. Q3 is 4 times -7, all divisible by the distance from Q3 all the way to Q5, so it's at -6, so from here to here is 6 units, so this is really 6 squared. And the directional vector pointing up, what's the directional Q3 pointing towards 5? The directional vector is J. And I'm running out of space and I don't want to go overboard on that side, so I'll just continue on the next line. So this is, again, 9.0, so I'm doing this equation, 9.0 times 10 to the 9. Q4 is here, it's 5 coulombs, 5.0 coulombs. And Q5 is -7 coulombs. And what's the distance between these two particles? They're not in diagonal, they're axis aligned, so we can actually just say the distance is 3 units, so it's 3 squared. And what's the direction of 4 pointing in 5? It's along the I-axis, so this is I. We can rearrange these terms into i's and j's, but this is fundamentally the answer. It's a lot of calculations, a lot of numerical work in terms of plugging into a calculator, and that's not the point. Setting up this equation and saying we can do it, right, is what physics is about. And we don't want to spend time doing numerical work too much because it's time consuming. So I expect this is the answer I'm expecting you to write for the force of the fifth particle. Okay, anyway.